Hello everyone. In the last class, we have seen the derivation of convolution and we have seen what is convolution and intuition to convolution. So, in this particular module or in this particular class, what we are going to discuss is problems with respect to only discrete time convolution system, and in the next class we will see problems about continuous time convolution. Okay, so let us begin. So the first question here is, compute y of n is equal to x of n convolution h of n. So you have to compute the convolution. So they have given what is this x of n and h of n. So what is this x of n which is given? X of n is equal to 2, 1, minus 1 and 3. So what is this arrow indicates? The arrow indicates that the value of x of n is 1 at the origin. So this arrow indicates the value of x of n at the origin. So if it is given normally like h of n is equal to 1 minus 1 2, here it starts from the origin itself like 0, 1 and 2. So what should be our approach to solve the problem? Okay, 1 minute. Yeah, so there was an arrow here. So now the first thing what you have to do is you have to express this signal in terms of delta function. So how do you express that? It's easy. So x of n is equal to 2 into del of, because this is at 0, so this is at minus 1, 1 and 2. So del of n plus 1 plus, next what is there, 1. 1 into del of n plus minus 1. Okay, minus 1 del of n minus 1, then plus 3 into del of n minus 2. So this is how you represent in terms of del. Similarly, we can write for h of n. So how can I write for h of n? H of n is equal to 1 del of n, because it starts at the origin here, like n is equal to 0, 1, 2. Here they have given the arrow mark, so this is at 0. Okay, so next minus 1 del of n minus 1 plus 2 into del of n minus 2. Okay, now let's do the convolution. It's easy. X of n convolution h of n. So when you convolute two delta function, just observe what I am doing. Okay, now let me take blue color. Okay, so we will take one by one. So first we will take 2 del of n plus 1 and convolute it. So convolution of 2 delta, it's just direct multiplication. So 2 ones are 2, del of n plus 1 into n is n plus 1 here, then minus 2 del of n. So this one and this one, 2 into minus 1 minus 2, del of n plus 1 into del of n minus 1 is equal to del of n, because n plus 1 minus 1 cancels and you will get del of n. Then 2 2s are 4, so this one and this one I am taking 4 into del of n minus 2 plus 1 is minus 1. Okay, so we have finished the first part. So this one is over. We will take this one and multiply. 1 into del of n into 1 into del of n is nothing but 1 into del of n. See why I am writing below this one, so that we can add easily. Okay, then 1 into del of n minus 1 into del of n minus 1 is minus 1 into del of n minus 1. Okay, then 1 into del of n into 2 into del of n minus 2, which is equal to 2 into del of n minus 2. So we have finished first one, second one. We'll take the third one. Minus 1 into del of n minus 1 into 1 into del of n, which is equal to minus 1 del of n minus 1. Then minus 1 into del of n minus 1 into minus 1 into del of n minus 1, minus into minus is plus del of n minus 1 into del of n minus 1, just n minus 2. Then minus 1 into del of n minus 1 into plus 2 del of n minus 2 is plus 2 del of n minus 2 minus 1 is minus 3. Then we will take the last one, 3 del of n minus 2 into 1 del of n, which is equal to 3 into del of n minus 2. Then 3 into del of n minus 2 into minus 1 into del of n minus 1, which is equal to minus 3 del of n minus 3. 3 del of n minus 2 into 2 del of n minus 2 is plus 6 del of n minus 4. So now we will add. Okay, so this one I'll write as it is, 2 into del of n plus 1. So minus 2 plus 1 is minus 1 del of n. Then 4 minus 2 is plus 2 del of n minus 1. Then 3, 4, 5, 6. So plus 6 into del of n minus 2. Then minus 3 plus 2 is minus 1 del of n minus 3. So actually I have made a mistake here. This should be minus 2. So this will be equal to minus 5. Okay, then plus 6 of del of n minus 4. So this is as it is. Okay, now how do you represent this in terms of signal? Yes, we will do it. Yeah, so it starts from minus 1, it goes up till 4. So first we'll mark it. So minus 1, 0, 1, 2, 3 and 4. So now what is the value at n is equal to minus 1? It is 2. So let me represent that. So this is 2. At n is equal to 0, it is minus 1. At n is equal to 1, it's again 2. At n is equal to 2, it is 6. And n is equal to 3, it is 5. And n is equal to 4, it is again 6. So you have to write the values here. So 2 minus 1, 2, 6. At 3, it's actually minus 5. Okay, so this is minus 5 here. Okay, so minus 5 and 6. So this is how you solve the problem. So if they have given x of n is equal to 2, 1, minus 1, 3 and h of n is equal to 1, minus 1 and 2 expressed in terms of delta function, and then you do the convolution as I have done here, and after that you have to solve that and you have to simplify that and you have to plot that. So then only you will get the marks. Okay, now so I have solved one problem. Similarly you can solve the other problems here. So they have given two delta function directly. So you can do it. Then here 1 to 1 and 2 minus 1 and 2 origin they have given here. It's in the same fashion you can solve it. And here x of n they have given. So this is a delta function. So here you need not worry, because h of n is given and you can solve it easily. So there is no need to worry. So just you substitute the value, like n is equal to, they have given, you have to plot it, and like -1 0 1 2, plot the values here and express in terms of delta function and repeat the procedure. Okay, now we will go to a different kind of problem. So the main motive here is to solve different kinds of problems. Okay, so in the previous one we have expressed in terms of del of a del function. So here we will see what is the variation. So here x of n is given. So every, so in this class you have to compute convolution. So x of n will be given, h of n will be given. So what will be the variation in x of n and h of n, and how do we compute the convolution? So that thing you have to observe here. So here x of n is given as delta function here, delta of n plus 1 minus 2 into del of n plus 3 into del of n minus 1. Okay, then here what is h of n they have given? They have given as unit step function u of n plus 1 minus u of n minus 6. So we have to compute the convolution. So x of n convolution h of n. So when they have given like this, so uh, convolution of del function and unit step function, you will get unit step function itself. It is a similar way, take individually and multiply. Okay, the same step. So u of n plus 2 minus u of n minus 5, because n minus 6 here plus 1 here. Okay, then we will take this one, minus 2 of del of n, and just multiply. So this one and this one. So minus 2 u of n plus 1 and plus 2 u of n minus 6. Then the final one, 3 del of n minus 1. So 3 del of n minus 1 into u of n plus 1. So that's equal to 3 u of n, and this one you have to multiply. So it will be, I'll write it here, minus 3 u of n minus 7, because minus 1 and minus 6. Now how do we plot this? So if you go back to the first module, I have told you how to plot this unit step. So don't worry, again we will have a revision here. Okay, so n is less than minus 2, y of n is equal to 0. So n varies from -2 to so first thing what you have to do is you have to arrange this one properly, otherwise you can't plot the signal. So let me arrange this signal here. So first thing what you will get is u of n plus 2, then minus 2 u of n plus 1, then 3 u of n. Otherwise it will be difficult to write it. So then minus u of n minus 5. Just I am writing in a proper order, like -2 -1 0, in that fashion I am writing. Okay, so observe, just observe, 2 u of n minus 6 and minus 3 u of n minus 7. Okay, now we will plot this. So how do we plot this unit step function? So n is less than -2. So this is minus 2, so n is less than minus 2, y of n is equal to 0. Then minus 2 to minus 1. So now let me get back to the form here. Minus 2 to 1. So y of n will be the previous value 0 plus what is the magnitude here? 1. So 0 plus 1, 1. So I have told you how do you plot this unit step function in the basic of signals in the last module. So this is just the refreshment for you. Okay. So n varies from, so minus 2 to 1 is over, from 1 to 0. So minus 1 to, because here minus 1 and 0. So what will be our y of n? 0 plus 1 and here it is minus 2. Minus 2 which will be equal to minus 1. Okay. Step by step we will go. Slowly we will go. Don't worry about that. Okay. Then n from 0 to n is equal to 5. So 0 to 5. What is the value of y of n? 0 plus 1 minus 2. So 0 plus 1 minus 2 and plus 3. So which is equal to 2. Then n varies from 0 to 5 is over. So 5 to 6. 5 to 6. Y of n is equal to 0 plus 1 minus 2 plus 3. And what's the magnitude here? Minus 1. So it is equal to 1. So now n varies from 5 to 6 over 6 to 7. So 6 to 7. What is your y of n? Y of n is equal to 0 plus 1 minus 2 plus 3 minus 1 and plus 2. So plus 2 which is equal to 3. Now what is remaining? N is greater than or equal to 7. So your y of n again 0, 1, 2, 3, 1, 2 and minus 3. So this thing will be, so these things will be the previous value only, 3 minus 3 which is equal to 0. So I wanted to show you methodically how to solve. Otherwise I could have done. Okay. So now we will plot this one. So how do you plot this one? So n varies from minus 2 to, so see here, minus 2 to 7. So see this one, n varies from minus 2 to 7. So we have to have all the values from, right from minus 2 to 7. So let us first write the values like minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6 and 7. So n is less than minus 2, 0. No need to plot. So n varies from minus 2 to 1. What is the value? 1. So 1. Next, n varies from minus 1 to 0. What is the value? Minus 1. Okay. Then n varies from 0 to 5. So 0, 1, 2, 3, 4, the value will be 2. So 0. Okay, sorry. So 0, 1, 2, 3 and 4, the value will be 2. Okay. Then from 5 to 6, value is 1. So 5. Then n varies from 6 to 7 is equal to 3. Then n is greater than 7, its value is 0. Because n is less than 7, not equal to 7. So the value will be 3 here. So understand. So understanding the mathematical expression is also very important to plot this one. So this is how you plot. So we have solved this one. So for you homework, x of n is equal to 3 of del of n plus 1 minus 2 into del of n plus del of n minus 2 and h of n they have given. Find the convolution of these two. Same procedure. What I have done, the same procedure you have to follow. Then what is the second question? X of n is equal to u of n plus 1 minus u of n minus 2, and h of n is equal to u of n minus u of n minus 3. So how do you solve this? Write it. X of n is equal to 1 from minus 1 to n less than 1, because it's only up to, because you are minusing it. Okay, so this will come up to 1, and h of n will be equal to 1 for n varies from 0 to 2, because you are minusing it. You plot it, so, and you minus that, it will vary only from this range to this range, and express these two in terms of del function as previous, and then solve. So this is the hint which I have given you to solve the problem. Okay, so let me go to the next variety of problem. Okay, so I am solving one problem in each cases and giving you the homework. So what I expect from you is to solve that. Okay. Now, so this is a different breed of problem. This is not a different breed. Just the same thing. Okay. You have to express in terms of del, and you have to do the problem. Okay. So what is the question? X of n is equal to u of n plus 1 minus u of n minus 2. So if you want to plot that, so it will, like, it will start from minus 1, it will go on, and n is equal to 2 to, it will go on. So yeah, if you minus that, it will vary from minus 1 to 1, right? So you will have like this, and you will have like this. So if you minus this, the range will be minus 1 to 1. Okay. I hope you understood this one. So u of n plus 1 minus u of n minus 2. So this will start from minus 1, and it will go on like this. And this one, u of n minus 2, it will start from 2 and go on. If you minus that, what will be the range? From minus 1 to 1. So this will be only remaining. So we will express that mathematically. So first thing, what we will do is we will express that mathematically, so that it is helpful to solve the problem. Okay, so this one, x of n is equal to 1 for n ranges between minus 1 to plus 1, and h of n is equal to, write it as it is. Okay, no problem with that. Now, x of n, we have to express in terms of del of n. How can we write it? So, del of n plus 1 plus del of n plus del of n minus 1. Because, I have shown you previously. So, this will be like minus 1, 1. Because when you minus, only this thing remains. Okay. Now, h of n will be as it is, u of n plus 2. Now, let us do the convolution. X of n, convolution h of n. So, what will be the convolution? So, del of n plus 1 into u of n plus 2, which is equal to u of n plus 3. Del of n into convolution with u of n plus 2, u of n plus 2. Del of n minus 1 convolution with u of n plus 2, u of n plus 1. So now again you have to write like before to plot this one. So n less than minus 3, y of n is equal to 0. So I will go fast here only in this section, because it's the same thing I'm repeating. So minus 3 to minus 2, because minus 3 to minus 2, y of n is equal to 0 plus, what is the magnitude? 1. So 1. and n varies from -2 to what is here, -1. So minus 1, y of n is equal to 0 plus 1 plus 1. So this is 2. And n greater than or equal to -1. What is the value of y of n? 0 plus 1 plus 2 plus 1 is equal to 3. So 0 plus 1 plus 2 plus 1 is equal to 3. Okay. So this should be 1, sorry. Okay. Because previous one plus 1. Okay. Now, how do we plot this? Again, I'm going to just show you roughly because you know it. So it varies from -3 to -1. So minus 3. Oh, sorry. -3 to n greater than -1. So it will go beyond -1. So -2, -1, 0. It goes beyond that value. So n less than -3. So y of n is equal to 0. -3 to -2, the value is 1 here. And n -2 to -1, the value is 2. Then n greater than -1, all the values are 3. So all the values are 3. So this pattern continues, this 3. Okay. So for 1, 2 and 3. So this is, this is the same thing like the previous one, only this one I had to show you. Okay. Okay. Now again, homework problem for you. So yeah, half of n u of n minus u of n minus 3, instead of step, there will be this one. So I have given the hint here for you how to do that. So just do that. Okay. So now we will go to the next problem, where x of n is equal to 2u of n plus 1 and h of n is equal to 3u of n minus 2. So how do we solve that? So what should be our approach? So what I need you to do is, like, just concentrate on this problem, and it will be easy for you. Okay. Okay. So now we know that. So now see the situation. Imagine you're plotting that one, this one. So it starts from -1, it goes on to infinity. So this one, it starts from +2 and it goes on up till infinity. So what should be your approach for solving this problem is the graphical method here. Okay. So first you have to plot the signal, and then there will be two different cases. So in the intuition of convolution, I have explained you one signal. What is this convolution? One signal you are keeping constant, and the second signal you are flipping it and you are moving it, so that you are taking the area. So that intuition I want you to bring here. So the approach to this problem is, first we will write x of k. So what is the first we will write what is this convolution. Okay. So so that you will understand. So y of n is equal to x of n convolution h of n. Okay. For discrete time. Okay. So this is summation k varies from -infinity to +infinity. So minus infinity to infinity, x of k into h of n minus k. So x of k, from this one I can directly get whatever I plot, I can take it as x of k, because k is the dummy variable there. Instead of n, I can replace with k. But what about h of n minus k? So first I have to plot h of k, then h of minus k I will do, then h of n minus k I will do. So please observe this carefully. How do you solve this problem? First we will write x of k. So what is this convolution intuition I told? One signal will remain constant, the second signal moves. So which is that signal, second signal which is moving? So this x of k will be there. H of n minus k, you are flipping, shifting, and doing the taking the area. So that is the intuition to convolution. So using that we are going to solve this problem. So first we will plot this x of k. So x of k. So x of k. So if you observe, n starts from -1. So I will take this one. Okay. So first thing you have to plot. Okay. So how does the signal looks like? So I'm using this software here. So that's what I'm feeling. Otherwise, if I had a pen and pencil, I would have done it easily. Okay. N is equal to -1, 0, 1, 2, dash, dash, dash. So magnitude is 2 here. So what I have done, I have plotted x of n. But since we are doing convolution, I am taking the dummy variable as k. So x of k I have plotted. Okay. So n is equal to -1 to this one. So I have plotted this one. Okay. Then similarly h of k you plot. So how do you plot this h of k? So let me take the green ink, and n is equal to 2 to infinity. So same thing, same logic, but the magnitude here is 3. Okay. Okay. Now this will start from 2, 3, 4, 5. So this continues, and what is the magnitude? Magnitude is 3. Okay. So this is h of k. But see the derivation of this convolution or the formula for convolution. X of k, let it be as it is. What we want? H of n minus k. So first we will get what is this h of minus k. Then we will do h of n minus k. So it will be easy for you. So h of minus k is nothing but the mirror image of this one. So just flip it. So if you flip it, how does it, how can we see this one? -2, -3, -4, and -5. What's the magnitude? Magnitude is 3. Okay. So the magnitude is 3 here. So while drawing, make sure it is straight line. Okay. Then h of n minus k. So h of n minus k, h of n minus k, same thing, add n to it. So n minus 5, n minus 4, n minus 3, n minus 2. The plot remains the same. Down you are adding the n. So 1 minute, sorry for that. Draw it neatly. So this one. Okay. Yeah. So this will be n minus 3. So n minus 2. This will be n minus 3, n minus 4, n minus 5, and so on. So this will be 3. So this is the initial step which you have to follow for this kind of problems. So first you have to plot this one. So our first thing has been done properly. Then what I told you, convolution, when I gave you the idea of convolution, what I told you, this x of k. So this signal, okay, how can I explain you? Okay. So this signal x of k, okay. So this signal x of k will remain as it is. So our second signal h of n minus k, there will be two cases. What will be the two cases? So let me take this h of n minus k here. 1 minute. Yeah, to current page. Okay. So this one, case one, when n minus 2 is lesser than minus 1. So it will be here. So when it's when I gave you the intuition, what I told you. So this point, where is this? N minus 1. So when n minus 2 is lesser than minus 1, what is the case? And when n minus 2 is greater than minus 1, so what I'm doing, I'm moving this one to the right side. So those two cases you have to consider. So when n minus 2 is less than 1, if you convolve here, nothing will be there, right? Output will be 0. But in the second case, what happens? So in the second case, what happens is we are moving this one. So n minus 2 is less than minus 1. So output will be 0. In the second case, so there will be overlapping. So if you observe this one, so there will be overlapping. So let uh, consider this case. So there will be overlapping of these two signal, and you have to find the area between these two overlapped signals. So I'm not able to show you overlapped because I'm moving. So case 1, when n minus 2 is less than minus 1, so output will be 0 because convolution of these two, 0 into something. Okay. So n minus 2 greater than minus 1. So there will be this overlapping here. So that overlapping you have to find out. So the range will be from minus 1 to n minus 2. So you can observe here, the green signal x of k, it is starts from minus 1 and it overlaps up till n minus 2. So that intuition you want to bring here to solve this problem. So I am moving this signal. So it's moving from left to right. So this h of n minus k, when it is less than n minus 2 less than minus 1, output is 0. Then it's starting to come here and there is a overlapping. That case 2, it starts from overlapping starts from this point. So this minus 1, and it will go up till n minus 2. So that intuition you should get to solve this problem. Okay. So we will do that mathematically. So case 1, n minus 2 is less than minus 1. Why it is less than minus 1? Because this x of k is constant. So observe this x of k. It is like a statue which doesn't move. But this is like a window screen, h of n minus k. So n minus 2 is less than, so this n minus 2 is of h of n minus k, which is less than minus 1. So what will be your convolution y of n? I can directly write y of n is equal to 0. We will take case 2. So case 2, when this moves, that is n minus 2 is greater than or equal to minus 1, then n will be greater than or equal to minus 1. Minus 2 will go that side, it is plus 2. So n is greater than or equal to plus 1. Okay. So this is case 1. So this is case 2. So what will be your y of n? Convolution. So take this problem. So take this formula. K varies from minus 1 to n minus 2, because you have to understand there is a overlapping. So that overlapping, from where to where you have to consider, from minus 1 to n minus 2, because I have showed you this x of k is constant there, it is not moving. H of n minus k is moving just like a screen. So what is the overlapping between these two? So if you consider this has overlapped on this one, it starts from minus 1 up till n minus 2, there will be overlap. So we are considering that range. So consider this as a overlapping. Okay. So it starts from minus 1 to n minus 2. Then what is this one? X of k. So what is the magnitude of x of k? 2. Directly we can write. And h of n minus k. What is the magnitude of h of n minus k? It is 3. So 3 2s are 6. I'll bring it outside. Then how do you solve this? Using mathematical formula n minus 2. So upper limit minus the lower limit. So that will be plus 1. And you have to add plus 1 to this one. So this is how you solve when this kind of limit is given using mathematics. Okay. So you have solved this one in mathematics. I'm just using that one. So 6 into n is your answer. So therefore your answer will be, so let me write it in green. Y of n is equal to 0 when n less than minus 1. So this condition. And y of n is equal to 6n when n greater than or equal to 1. So this is how you solve this problem. Okay. So first write x of k, then h of k, then h of minus k, then h of n minus k, then shift this h of n minus k. So case 1 when n minus 2 less than minus 1, case 2 n minus 2 greater than minus 1. So why I have considered this case? Because convolution is, you are finding the area. So what we have done is like first flipping, shifting, multiplying and adding actually the area means. So that is nothing but your convolution. So that one we have solved here. Okay. Now using the same technique, for you there is a homework. X of n is equal to 3 of u of n minus 1 and h of n is equal to u of n plus 3. So no need to worry. So first you plot this one. How do you plot this one? X of k 1 2 3. So there will be this 3 3 3 and h of k will be from minus 3 it will start. Minus 2 minus 1 0. The magnitude will be 1. Then do, so this will continue. Then h of minus k, flip it. Then h of n minus k, add n to this one. N minus 3, n minus 2, n minus 1. And then using the previous thing, you can solve this problem. So same technique. So I'm not going to solve that here. Okay. Let us take another kind of problem so that, uh, it helps you to get, some intuition into convolution. Okay. Now x of n is equal to half of n into u of n minus 1 and h of n is equal to u of n plus 3. So what is your approach to solve this problem? Okay. First what I told you, write the convolution formula. So what is the convolution formula? Y of n is equal to x of n convolution h of n, and y of n is equal to summation k varies from minus infinity to plus infinity x of k h of n minus k. So what we want? X of k then h of n minus k to solve this kind of problem. So x of n they have given half of n u of n minus 1. So x of k, what is there to plot? Let us plot. So it starts from 1 and it goes on. So let me plot this neatly. Okay. So it starts from 1 and it goes on. Okay. So this is half power n. So half of 1, half of 2, half of 3. So your value goes on decreasing because it is half, right? So you have to write here half of 1, half of 2, half of 3, half of 4. It goes on like this. So this is your x of k. Now h of n minus k. So let us plot first h of k, then h of minus k and h of n minus k. Then same thing, two cases. Okay. H of k, how can we plot? It starts from n is equal to minus 3, because here it is there minus 2, minus 1, 0. So what's the magnitude? 1. Okay. Then what we want? H of minus k. What I told you, it is just like taking the mirror image. So 3, 2, 1. And what's the magnitude here? 1. Then h of n minus k is simple. So write it below x of k, so that you can take the product, or the x of k into h of n minus k, so that it will be easy to visualize that. Okay. Mm, yeah, same thing, you're adding n at the bottom, that's it. Okay. So this is n plus 3, this is n plus 2, so this is n plus 1, and the magnitude is 1 here. So now we will take two cases. What is that two case? When n plus 3, so this one is lesser than 1, so your output will be 0, and n plus 3 is greater than 1, so there will be overlapping. What is the area between, like, those 2 points? From k varies from 1 to n plus 3. Okay. So case 1 I will solve here. So case 1, when n plus 3 is less than 1. So n is lesser than 1 minus 3. So n is lesser than minus 2. Your y of n will be equal to 0. Now case 2, when n plus 3 is greater than 1. So what I will do is, okay, so what I will do is, I'll take to the next page, so that it will be easy for you to understand case 2. Okay. Okay. So we will take case 2 here. So case 2, if n plus 3 is greater than 1 and n is greater than 1 minus 3 and n is greater than or equal to minus 2. So this is our case 2. So what is y of n? X of n convolution, x of n summation k varies from, what is the range? From 1 to n plus 3. From 1 to n plus 3. What is the value of x of k? Half power k, because x of k. So I'll write the convolution definition here, so that it will be easy for you to relate. Y of n is equal to x of n convolution h of n, which is equal to summation k varies from minus infinity to infinity, x of k into h of n minus k. So what is this x of k? So this is your x of k. So half power k, because in general, if it was n, you would have written half power n. So because it is x of k, it is half power k. K, don't confuse with that. So from where this k come and all? Then what you want? H of n minus k. So the magnitude here is 1. Okay. So instead of this 1, if there was like half, or same thing, if it has if it had the same trend of x of k, what you had done? Half of n minus k for h of n minus k. Okay. Just remember that. So since we had 1, there is no problem here. If it was having the same trend of x of k, like half power 1 or half square or half of 3, like that, it would have been half of n minus k here. Okay, so don't confuse, just follow the trend. So x of k I have written, h of n minus k I have written. So now, in order to solve this, so we have to bring this in this form so that we can apply the formula easily. So what formula? Summation k varies from 0 to n, a power k is equal to 1 minus a power n plus 1 into 1 minus a. So if we bring this you know our main equation m into this form, it will be easy for us to simplify. So my approach is to bring in this form. Okay, so use this formula of star. Okay, so what I will do is, so please observe, so k is equal to 1 or k minus 1 is equal to 0. K is equal to 3 plus n, I'll write it as it is, then half of k. Now put k minus 1 is equal to l. So what happens when k is equal to 1, and what happens when k is equal to n plus 3? So k is equal to 1, l is equal to 0, k is equal to n plus 3, so l is equal to k minus 1, so n plus 3 minus 1, so your l will be equal to n plus 2. So how this equation gets modified? So this one, l varies from 0 to l varies from n plus 2. Half of k is nothing but k minus 1 is equal to l, k is equal to l plus 1. Now let us bring this, so half of l plus 1, half of l into half. So half I'll bring outside, and summation l varies from 0 to l varies from n plus 2, half of l. Now apply this formula here. So now apply this formula. So what you will get? Half outside, then 1 minus a power n plus 1 divided by 1 minus a. So if you simplify, you will get as this one, 1 minus half of n plus 3. So you may say, from where sir this n plus 3? So just l is equal to k minus 1, l is equal to n plus 2. So this l, write it as n plus 2, and then you will get the, because you see the limits of l, 0 to l plus 2. So this is how you solve, because 1 minus a to the power of n plus 1. So your n you have to write, because k varies from 0 to n. So 1 minus a power n plus 1. So using that formula, you have to express that one, and you will get this one. So same thing, but you have to express what I want you to keep in mind is, express in terms of this formula, so that it is easy to simplify. Okay, so now, yeah, again, homework problem for you. X of n is equal to 1 by 3 power n, and 2 of u of n plus 1, this one. And here I have given some clue. Take that and solve that, and we will wrap it up this class with the last problem. So in signals, it's like you have to solve lots and lots of problems and get some intuition. Okay, so x of n is equal to a power of n u of n. So 0, a lies between 0 to 1. Okay, and h of n is equal to u of minus n minus 2. So the same thing you have to follow here. Okay, I will give you some intuition. and then you can solve, because everything, if I solve it will not be good. Like, you should also put some effort. Okay, so yeah, the first thing what you have to write is formula for convolution. Y of n is equal to x of n convolution h of n. So what is this equal to? Summation k varies from minus infinity to plus infinity, x of k into h of n minus k. Now case 1. Case 1, if n less than 0, and in case 2, I have to write, but before that, what we have to do? We have to plot this x of k and h of n minus k. So we will plot that. So we have x of n is equal to a power of n u of n. But this a lies between 0 to 1. So how can you plot this? So let's plot first x of k. So x of k, okay, starts from a starts from n starts from 0, 1, 2, dash dash dash. So a power of n. So a power 0, a power 1, a power 2. So how this varies? So like this: a power 0, a power 1, a power 2, dash dash dash. You may say it should go on increasing, but see the value of a, it's a fraction, so it should go on decreasing. Okay, because it lies between 0 and 1. So this is your x of k. So why I have taken this problem is u of minus n minus 2. So this should not confuse you. Okay, so I have taken this problem here. So how do you solve this one? So do not worry. So first we will plot this h of k. So it starts from minus 2, minus 3, it goes up till ulta minus 4, because it is minus n minus 2. Normally, how do you start this one? 2, 3, 4, like that, right? So here it is like minus of minus n minus 2, so it will be like this. So this one will be minus 2, minus 3, minus 4, and the magnitude will be 1. So this will be your h of k. So h of minus k will be reverse. So h of minus k will be reverse. 2, 3, 4, 1, 1, 1. Okay. Then h of n minus k. Here only I will write n plus 2, n plus 3, n plus 1. So this is your h of n minus k. So this is your x of k. Then take the two condition. Okay, and then solve it. So case 1 is like n plus 2 is less than or equal to 0. So n is less than or equal to minus 2. What will be your y of n? Y of n, observe here, in the last thing, you had your signal on the left side, so that there was no overlapping. But here, n plus 2 less than 0, there is overlapping. So this range k varies from 0 to infinity, a power k into 1. So a power k is nothing but 1 by 1 minus a. So this is your standard formula. So this is your case 1. So there will be overlapping. Okay, so that overlapping starts from 0 to infinity, and your magnitude is a power k into 1. For second one, n plus 2 greater than 0, the overlapping starts from n plus 2, and it goes on up till infinity. So case 2 I'll write here only. So I'll erase this case 1. Okay. So case 2, n plus 2 greater than 0. So this is a different kind of problem. Usually in case 1 we did not had overlapping. So I had done this problem because there is overlapping when this kind of thing comes, like minus n minus 2. So you have to be very careful. So this u of minus n, when it comes, there will be overlapping in case 1 as well as case 2. So please, be careful. So I had solved this problem here. So n is greater than minus 2. So y of n is equal to k varies from n plus 2. So the overlapping starts from n plus 2 and it goes up till infinity, because you keep this x of k constant and take two cases when n plus 2 is less than 0 and n plus 2 greater than 0. So case 1, it will this will lie here somewhere because it's less than 0. It is greater than 0, case 2, here it will lie. So it overlapping starts from n plus 2 up till infinity. So n plus 2 up till infinity, what is the magnitude? A power k into 1, because it's a power 0, a power 1, a squared, like that. And what you will get, this is a power n plus 2 divided by 1 minus a. So using the formula you can solve this one. Okay. So what I suggest you is, like, solve many kind of problems, and I have given just an example here. So it's up to you to solve many problems and get the solution. So take this homework here: x of n is equal to a power of n u of n, and see here u of minus n plus 1, and here I have given as u of minus n and u of n. So consider this homework problem also seriously, and solve this one. It's not easy, you'll not get easily anything. Okay. So yeah, in the next class we will solve about the so now we have solved about discrete convolution problems. In the next class we will solve continuous convolution problems.